We're going to do another one of these, but this time we're going to do one that has a fraction on the inside. Okay, so we're going to use the epsilon delta definition limit to prove this one. So as always with these, you should go ahead and just kind of go through and label what's been given. So in this case, the x of O, that's going to be 4. Our f of x is going to be x over 2 plus 6. And your limit is going to be 8. Okay, so we want to label these things first. Whenever you do these kind of proofs, you always want to start out with the same general statement. You're going to say, for each epsilon greater than 0, so again, this line needs to always be in there whenever you're doing these. The notes, the way I have it written out here in the notes is the way that you should be writing these out in the test. So for each epsilon greater than 0, we say there exists delta greater than 0 such that if. Okay, so this line always needs to be in there when you're doing these. This is part of your proof. Okay, so now what we're going to do is we're going to fill in based on these things that are given here. You're going to be working with these to fill in. So what you do is you start with f of x minus L. So we're going to do x over 2 plus 6 minus L. So that's that one right there. And we said that's going to be less than epsilon. Remember, you're always starting with this statement, f of x minus L less than epsilon. You're starting with this one, and then we're going to walk through it the other way. So first we do this. And what you want to try and do is, when we talked about this earlier, we want to look for an absolute value of x minus 4 because the 4 is the number that this is going to this time. So we need to manipulate this to where somehow we get an absolute value of x minus 4, because then that's we're going to use for the rest of the proof. So let's do that. We're going to do x over 2, and we have minus 2 here. Alright, now at this point, if you're wondering how we can get the 4 out of it, we need to do a factoring step. Because remember, we need to get the x by itself inside. So this may not be quite as obvious to see, but this is what you want to do. You want to factor out a 1/2, and so you're just going to get an x in there. If I take negative 2, remember when you're factoring something out, it's a form of division. So if I take negative 2 and divide it by 1/2, you're multiplying by the reciprocal. So in fact what happens is you're going to get negative 4 that comes out of that. Okay. So what you can do there is you can take the 1/2 on the outside of the absolute value, and now we see there that we have the an absolute value x minus 4, which is what you're trying to do. And then you multiply by 1/2, or multiply both sides. I should say multiply both sides by 2, because we want to clear out the 1/2 and get the absolute value by itself. So if we multiply both sides by 2, then you end up with this. So you have absolute value x minus 4 is less than 2 epsilon. So what we're going to do is we're going to let epsilon equal, let delta here. Okay, let delta equal 2 epsilon. Now, this right here is kind of like considered scratch work, and so now the proof actually begins. What we're going to do is, if you let delta equal this, we're going to walk backwards until we end up getting f of x minus L. So again, the reason why we're doing this is because proofs go both directions. We show one side getting down to what we have to let our delta equal. We put that in to show that we should get back to what we started with. Okay, so we're going to let that, we start with that one. And then this is what you're going to do. So you say something like that. Hence, if something like that, if you have this x minus 4 here is less than epsilon equals 2 epsilon here. So we got that statement. So we're saying that we're going to substitute the delta with the 2 epsilon, because that's what we originally found it should be. We're now just going to walk backwards. Okay, so now we can say that with this, absolute value is always greater than 0 anyway, so we can say x minus 4 here, we can say is less than 2 epsilon. And we're going to now work backwards. We're going to divide both sides by 2, which gets you the 1/2 outside here. we can put the 1/2 inside. So 1/2 and then x minus 4 on the inside there, less than epsilon. And then once it's inside, we can multiply that one through, and we get this here, we get a 1/2 x minus 2. And what we want to do now is just rewrite it like we originally had. We know that we can replace the -2 with 6 minus 8, and then we get x over 2 plus 6 minus 8 less than epsilon. And that does actually bring us back to this, which is what you always want to come to as a final thing. So if you have this, starting with this, we've shown that you can end up with this. Absolute value f of x minus L less than epsilon. This is the last statement that you do want to put down. Just again, this is your original f of x here. We have a minus L that was originally given.